Hello, guys. You are welcome to this lecture. We are going to continue with discrete probability distributions. This lecture will cover the binomial distribution. Okay, so we'll look at what the binomial distribution is and how you compute the mean and the variance for the binomial distribution. Okay. So binomial experiments are probability experiments in which there are only two outcomes, okay? Or the experiment can be reduced to two outcomes. Whenever this is the case, then you have what is called a binomial distribution, and then you can use the formulas for computing the mean, variance, standard deviation, and stuff for that experiment or for that, that probability experiments, okay? So, for example, when a coin is tossed, it can land heads or tails. All right. When a baby is born, it will either be male or female. So, if you are looking at the sexes, you know it's just male or female. In a football game, the team will either win or lose. So, two outcomes. If you answer a true or false question, all right, then the answer can be either true or false. So the outcomes are two. Or sometimes you can reduce the outcome to only two outcomes, right? The situation to only two outcomes. For example, a medical treatment can be classified as effective or ineffective. Okay, so two outcomes depending on the results. A person can be classified as having normal or abnormal blood pressure. So again, two outcomes. Okay, so in all of these cases, you can use the binomial distribution to compute some statistics and make decisions out of that. Even if you have a multi-choice question, you can still reduce it to just two outcomes, right? So even though there are 4 or 5 answer choices, you can classify, the outcome as either correct or incorrect. Okay. So there are a host of cases or situations that we can actually apply the binomial distribution to help us make decisions. Okay, so that is what the binomial distribution is. Each trial has only two outcomes. So that is, before you apply the binomial distribution, these are some things you must note. Okay, two outcomes, or the outcomes, you should be able to reduce the outcomes to only two. All right, and we would usually consider them as either success or failure. Okay, and there must be a fixed number of trials, not an infinite number. So you have 10 trials, you have 5 trials, you have 6 trials. The number of trials must be fixed. The outcomes of each trial must be independent of each other. Okay. So one outcome must not depend on the other one. If that is the case, if they are dependent, you can't use the binomial distribution or the formulas for a binomial distribution. So the trials must be independent of each other. And the probability of success must be the same for each of the trials. All right? For each trial, probability of getting, for example, if you toss a coin, probability of getting a head in the first trial must be the same, 1/2 in each case. All right, for each trial. All right. So once these requirements are satisfied, these 4 are satisfied, you can apply the binomial distribution. So the outcomes of a binomial experiment and the corresponding probabilities of these outcomes are called a binomial distribution. Okay. So often in binomial distribution, this is the notation that is often used. PS here, S here stands for success. Okay, this is the probability of success. F is for failure, so this is the probability of failure. Small p here is the probability of success. Okay, so probability of a head. When you toss a coin, for example, it's 1/2. So this will be 1/2. Q here will be the probability of failure. In the case of a coin, it's the same thing. It's 1/2 as well, right? Okay. So probability of success is P. And the probability of failure, remember, is a complement, right? And so the failure is 1 minus the probability of success, and it's often called Q. Okay, so Q is 1 minus P. N is the number of trials. X is your random variable, the number of successes, if you like. Okay, so X must be greater or equal to 0 and less than or equal to N. The number of successes cannot be greater than the number of trials, right? That makes sense. So X must lie between 0 and N. Okay, so these are some notations that you'll come across under binomial distribution. Okay, so finally, what is the formula for computing the probability of success for any binomial distribution? All right, so in a binomial experiment, the probability of exactly X successes in N trials is given by this formula. Okay, probability of X success is N factorial over N minus X factorial multiplied by P to the power X multiplied by Q to the power N minus X. Okay, so the first part here, all right, this part really talks about getting X successes out of the N trials, which is N combination X. All right. So the first part is, how do I get X successes when I perform N trials? That is really N combination X, and that is what this part is about. Okay. Okay. And then the other parts, of the formula has to do with the fact that each success has a probability of P. Okay. And it can occur X number of times. So that is why we have P to the X. And each failure has a probability of Q, and it can occur N minus X, right? Because if X is successes and you have N trials, then N minus X is the number of failure, right? So you have Q raised to the power N minus X. So if you put all that together, that's how you get this formula. Okay. So if you recognize that the the event is a binomial experiment, or you have a binomial distribution, and you want to compute the probability of success, you just apply this. Know the number of trials, know the successes that you want, and know the P, the probability of the success. Okay, this can be gotten from here, so this is not as important. The most important are your N, X, and P. Once you have that, you can compute the probability. Okay, so let's look at an example. A coin is tossed 3 times. Find the probability of getting exactly 2 heads. Okay, so we are going to use a binomial distribution, the binomial formula, to compute this. Okay, because the experiment is actually a binomial experiment, so we can do that. But also note that we can use sample spaces. Okay, so there's no one way of doing this for this particular case, right? But it's easier to use the binomial formula. You have to avoid the sample spaces because, for example, when you toss 10, for example, 10, when you toss a coin 10 times, so you note that getting the sample space will be much difficult to get than when they are just 3. So it's better to use the binomial formula in this case. Okay, so how do we get? A coin is tossed 3 times, so the number of trials is 3. We want the probability of getting 2 heads, so let X be 2. Now, when you toss a coin, the probability of each tossing the coin is just 1/2. The failure is also 1/2. So we have all the ingredients. So we plug them into the formula. Okay. The formula is N factorial over N minus X factorial, P to the X, Q to the N minus X. Okay. So plug these numbers into the formula and compute it. The probability of getting 2 heads is 0.375. Okay. So that's the probability. So we can also do it, as I said, using the sample space, right? If you toss 3 coins, you're going to have this. The probability of getting 2 heads, you have 2 heads here, 2 heads, 2 heads. You have 3 of them out of the total 8. right? So the probability of getting exactly 2 heads will be 3 out of 8, which is 0.375, the same as we got for the other one. Again, it is simpler here because we only have 3 coins. Okay, if you're doing 10 coins, 15 or so, then it's much difficult to do this, to get all the sample spaces, right? It's even confusing to get them. So this is much simpler in that case. But if you're not restricted and you only have a few trials, of course, nothing stops you from using sample space to do it. Let's look at a second example. If a pharmacy student randomly guesses at 5 multi-choice questions, find the probability that the student gets exactly 3 correct. Each question has 5 possible choices. Okay, suppose that the student doesn't want to study, and then all they want to do is go to the exam hall and guess randomly. Okay, at 5 multi-choice questions. The questions are only 5. What is the probability that the student gets 3? You know, maybe more than the pass mark or so, right? What is the probability they get exactly 3? Let's see the probability. Okay, so there are 5 multi-choice questions, which means the number of trials in this case is 5. Okay, the number of successes, we want 3 correct ones, so it's 3. The probability of success, you see, each question has 5 possible choices. So the probability of choosing the correct answer is 1 out of 5. Okay, and then the failure is 4 out of 5, right? Okay, so we have all the ingredients. We plug them into the probability formula. Probability of x equals 3 will be 5 factorial over all of these. Compute that and get 0.05. So probability of getting 3 out of 5 is like 5%. So your chances are very slim. So the lesson is that it's better to study, right? Understand the material than try to guess in order to pass. Okay, that's the message. Yeah. Okay, how do you then compute the mean and variance and standard deviation for a binomial distribution? Well, you can do what we did previously. Take each element, multiply by its probability and sum them up to get the mean and do the other stuff. But in the case of a binomial distribution, those formulas have been simplified. Okay, and so for a binomial distribution, to find the mean is just easy. You just take the number of trials and multiply by the probability of each trial. And the variance is given by this, n times b times q. And of course, the standard deviation is the square root of variance. So you have that. Okay. Again, these formulas are equivalent to the ones we've seen before, but they have just been simplified for a binomial distribution. So for a binomial distribution, instead of using the previous ones, just apply this. Okay, let's do an example. A coin is tossed 4 times. Okay, find the mean, the variance, and standard deviation of the number of heads that will be obtained. The coin is tossed how many times? 4 times. Okay, so the number of trials is 4. You toss a coin once, the probability is 1 over 2. The failure Q is 1 over 2. So the mean is just n times p. See, much simpler. You get 2. The variance is npq, so 4 times half, which is 1. And so the standard deviation is also 1. All right. So what does these numbers mean? Okay, they mean that when you do perform these experiments many times, okay, tossing 4 coins, you do that many times, the average number of heads that will appear is 2, and the standard deviation is 1. Okay, so again, these are theoretical numbers. All right, these are theoretical numbers. We haven't really performed the experiments. You can compute it alternatively using the previous formulas that we have seen before. Okay, so if you toss a coin 4 times, okay, you have an x the number of heads. For all those times, it's possible to get 0 heads, to get 1, to get 2, to get 3, to get 4 for all the 4 heads. And the probability of each of these is given by these numbers. right? You can write down the sample space and then you get these numbers. Okay, good. So to compute the mean, we can use the same expectation, the same formulas we had before. Take the elements, multiply by its probability, and then sum them up, and you get 2. All right? To compute the variance, square the elements, multiply by its probability, and then sum them, and then subtract the mean squared. Again, if you do that, you get 1, and the standard deviation is 1. So you get the same numbers, right, as we got using this simpler formulas. Okay? So it's easier to use these formulas to compute the numbers. Okay, that is the point here. Okay, so one last example. A life insurance company, okay, reported that 2% of all deaths in Ghana result in twins. Okay, if a random sample of 8,000 deaths is taken, find the mean, the variance, and the standard deviation of the number of deaths that will result in twins. Okay, so in this case, the total number will be the number of trials. So 800 deaths. The probability, okay, they said that probability of twins is 2%. So probability is 2 out of 100, which is 0.02. And then the failure, of course, will be 1 minus this, which is 0.98. So we have the numbers that we need. Find the mean, the variance, and standard deviation. The mean is just take n times the probability. So in this case, we have 8,000 multiplied by the probability of 0.02, that gives you 160. Okay? And then this, the variance is NPQ, take n times p times q, you have 156.8. And then the standard deviation is the square root of this, which is 12.5. So this means the average number of births will result in twins is 160. 160 births will result in twins. And the variance, all right, is 156.8 or 157, right? Okay, so this is the variance. And the standard deviation is 13, if you like, when you round it, when you get 13. All right? So that is how you apply the binomial distribution to compute these statistics for different problems. Okay, so here are some exercises that you can try on about the binomial distribution. Okay, I have several of them for you to try. So take a look at them. In the last bit, we'll come back and then we'll look at the Poisson distribution in our next lecture.